This session is going to be two examples where you actually have to find the derivative by the limit process. So if I have a function and I want to know the slope of the tangent line, which is the derivative, I'll say f's derivative at x, and this is the symbol for derivative, can be given by this right here. This is called the difference quotient. So I just need to fill in these blanks, like f of x plus delta x. Well, how do you find that? Here's a function. If I said find f of 2, most Algebra 1 students could tell you that means I need to find my f function and plug in a 2. So f of 2 would be 3 times 2 plus 5. So if I want to find f of x plus delta x, I will find my f function, which is right here, and I will put in an x plus delta x everywhere I see an x. So f of x plus delta x is 3 times x plus delta x plus 5. So this part right here belongs to this part right here. Put my subtract sign in here. Now f of x can be found right here. See, f of x is 3x plus 5. So 3x plus 5 goes here. And on the bottom you have a delta x. Now all you have to do from here is some algebra to clean this up. So you'll want to continue to write your limit. 3 times x plus delta x is 3x plus 3 delta x plus 5. Remember to distribute this negative, so minus 3x minus 5 all over delta x. And that will continue to be cleaned up. Bring your limit down, and the 3's will go away. Plus 5 minus 5 goes away, so I get 3 delta x over delta x, which is the same thing as the limit as delta x goes to 0 of 3, because your delta x is right here, will cancel. Remember, you can't do direct substitution yet because 0 over 0 is undefined, so you have to cancel these, and now you can do direct substitution. Substitute in a 0 everywhere I see a delta x, which is nowhere, which means that this answer is always 3, which means that my slope for this function is always 3, no matter what x is. That may be familiar because you might recognize that this is a slope-intercept form equation from Algebra 1, where this part right here is your slope. So that's why this slope is always 3. So the next example is a little bit longer because this has a squared term, but the process is still the same. You'll be finding a limit of a difference quotient where I need to find g's value at x plus delta x. Well, here's g right here, so I need to find the g function. Stick in an x plus delta x for both of these spots. So this will be a 2 times x plus delta x all squared minus x plus delta x. So here's g of x plus delta x. Then I will subtract g of x, which is 2x squared minus x. That can be found right here. G of x is 2x squared minus x all over delta x. From here, this is all just algebra cleaning this up. So 2 times x plus delta x all squared. That's what you get if you'd write this next to itself and FOIL it, which would be x squared plus 2x delta x plus delta x squared. And again, that comes from x plus delta x times x plus delta x. Then minus x minus delta x is from this right here. Distribute the negative, distribute this negative again, minus 2x squared plus x all over delta x, and bring your limit down. Continue cleaning this up. You can distribute the 2. So this would be a 2x squared plus 4x delta x plus 2 delta x squared from distributing this. Okay, minus x minus delta x minus 2x squared plus x. That's all on the top line. And we still have a delta x on the bottom line. And we see that some stuff will zero out up here on the top, like negative x and positive x, and negative 2x squared and positive 2x squared. And that will leave me with 4x delta x plus 2 delta x squared minus delta x all over delta x. Still have my limit over here. And I can't direct substitute still because I still have a delta x in the bottom, so let me try to cancel that with a delta x in the top. That means I need to factor a delta x out of the top. Which means I'm dividing a delta x out of each of these, which means that this is a 1. Delta x divided by delta x is a 1. That's a pretty common mistake. And now these delta x's will cancel each other out. And I have the limit as delta x goes to 0, 4x plus 2 delta x minus 1. So I direct substitute a 0 right here for delta x. So that answer is 4x minus 1. Okay, you might ask yourself, why does this have a variable in it? That's because the slope of this parabola changes depending on what x-coordinate you're at. You might remember a parabola looks like this, and the slope of these tangent lines keep changing as you go around this parabola. So you might have a slope here that's a steep negative slope. You might have a slope here that's a shallow negative slope, maybe one here that's 0. So see, these slopes keep changing depending on what x-coordinate you're at, and that's why this slope at the end has an x in it. You need to put in wherever x-coordinate you're at, and that will tell you a value for the slope. For instance, if I said find this slope at x equals 3, then the slope of the tangent line for this equation, this g function, when x equals 3 is 4 times 3 minus 1, or 11. So that's how you do that.